In front of us is a sample question where we can practice the ideas of one sample or two sample analysis. Let's see. The average percent of men had the best estimate of fat, had the best estimate of 14% fat content, and has a standard deviation of, well, we know that standard deviation is an error, so plus or minus 3% means the same way. In a certain city in the NCR, 30 men were sampled and had a total of 552% fat content. The city was known to have chains of several beer houses and steak houses. Determine if the existence of these leisure places has an effect on the average fat content of men. So we understand that what we needed to test is if these variables right here, the beer houses and the steak houses, has an effect. But what kind of effect do you want to test? Well, you need to decide on that. And, well, understandably and logically, what we wanted is to know whether it increases the fat content. So in that case, we have an idea that our H naught would say that the has no effect, and H1, which is alternative, has an effect, and what kind of effect? It will increase the fat content. And by doing so, we actually limit our analysis into a one-tail analysis. The reason is we only wanted to know if it increases the fat content, which means that we wanted to know whether a certain data is on the right side of the mean. Alright, so if this is the mean, if we wanted to know if it has an increasing effect to the mean, then we only wanted to know the things that is going on that side, and hence we only wanted to do on the one tail, on the right tail, on one tail on the right. Alright, so let's say, but another thing we need to do is to determine what value are we testing. So here we go. If you go back to the problem, there is a value called 14% and there's a value that is 3%. What are those values? Well, if I understand correctly, it says that it is the best estimate. I can get from that 14% is the mean, is an estimate of the mean of the population. And the standard deviation 3% stands for the standard deviation of the population distribution, which they also tried to estimate, so that's 3%. Remember that we cannot use these values directly because we're not sure whether the distribution of the population is a standard distribution. So what we do is we change these values into a sampling distribution value. Now, good thing for us in sample distribution, the mean of the population is the same thing. So let's just write it down, 14%. But how about the standard deviation of the population? Well, as we know, for us to get the standard deviation of the sampling distribution, and that's how we write it down, the sampling distribution of the sample means, that's equal to the standard deviation of the population divided by the square root of the sample size. Now notice that it says that 30 men were sampled. So this is the sample size of one sample. If you remember this, there's one sample, and inside of that one sample there are 30 elements. So the sample size is 30. So we should divide that by square root of 30. So we have 3% all over square root of 30. Let me grab my calculator to check what this thing is. Alright, the value according to my calculator right there is 5.48. 5.477 rounded off, 5.48. So let's just put it right there. 5.48. So that is the standard deviation of the sample means.